Hello Okuma fans, Charlie with the Gosiger application staff. Got another collision avoidance video for you today. We've done a couple of videos in the past about how to create tools, how to import tools, how to manipulate tools, how to set up the machining environment. But today we're going to go through the process of putting all of that information together and showing a procedure from start to finish on how to get your collision avoidance software on your Okuma Turning Center or multitasking machine ready to run a program. So our program today is fairly simple. I'm not trying to show off anything about the complexity of the machine, but if we look over here at our A turret, you'll see that I'm doing an OD turn, roughing a profile. It's just a couple of steps. Then I'll pick up a drill and do a couple of holes around the quadrants, 4 holes at the quadrants of the part. And then I'll mill with a 1/2 inch end mill a little square right in the front of the part. Then I'll have the sub spindle come over, pick it off, and move it to the other side. A couple of things I didn't do. I did not incorporate the lower turret, although everything that we're talking about here is applicable to that other side. I'm also not doing any kind of machining on the sub spindle because, again, just like this one, it applies to the theory that we're using will also apply to the sub spindle. So if you notice my collision avoidance system here, I've got absolutely nothing populated. I also have nothing mounted in my magazines right now. And given the capacity of the magazine, that's probably not the way your machine is going to be existing at the beginning. You probably already have some tools that are in the magazine, the standard stuff, but we want to go through it from scratch and just see how to get this thing ready to go. We've already created the tools in the graphics. That was a previous video. We've already created chucks, jaws, and material that are stored in our library. That's also another video, but now we're going to assemble all of them. So as the setup guy, I will have gotten my program, my packet of paperwork, Traveler, whatever my shop protocol is, and I loaded the program into the machine, and now I've got to start setting things up. First thing I'm going to do is I'm going to add my tools. And because I've already selected my program, you notice right up here it says, yep, CAS demo. That's my program that I'm using. That's already been loaded and selected. So now if I go over to my tool data tab, you'll notice that in my tool data page that I have a little icon here that shows me which tools are being used in this program. That's great. That's handy as all get out. Tool number 1, tool 100, and tool 200. That way I know which ones need to be loaded in if they're not already there. So under magazine info, I don't have anybody there. So let's just select where did I load tool number 1. This is a 45-degree turning tool. I'll put that in magazine position 1 by touching it on the unmounted tool list, say magazine attach, confirm that it really is position 1, and in it goes. Let's say that my drill is going into position 4, magazine attach, yes. And my flat end mill, let's put that somewhere else, like magazine number 6. Okay, so now those have all been installed in the magazine. That's ready to go, but my collision avoidance machining environment still hasn't been populated. So let's go ahead and do that. I'm going to start with spindle number 1 by touching spindle setup 1. I want to make sure that the jaw ID and the blank ID from this page are set to none before I do this. There are several different places where you can define graphics for collision avoidance, and if you have one of these areas populated, you can't populate through any of the other areas. So I want to make sure that this area is set to none. For the chuck, I'm going to get over here into the Edit Parameters page and see the jaw block position. By touching that, I want to make sure that's set to 0 as well, because that's another area for where the any kind of shift in the chuck. And then we'll touch the chuck parameter set. Make sure that chuck ID is set to none. If there is a chuck defined right here, I won't be able to delete it from the page I'm about to show you. Now that I've confirmed that jaw ID, blank ID, and chuck ID are all set to none, now I can cancel out of this. Now I'm going to go over to process shape, and this was covered extensively in the collision avoidance machining environment video, but let's do it again just to say we did. Touch the process shape, and because I've already defined everything, I'm going to add my jig and touch read so that it'll open my library. There's my B210A6 chuck. It's set. Now I'm going to add jigs. I'm going to read for the jaws that I created, and last I'll add a blank and read the 5-inch blank. Now you notice, let's move this over a little bit so we can see it. You notice that Okuma is smart about this software, and it knows to stack each of these components subsequently so that your jaws are not hidden within your chuck body. If you've defined your graphics properly, it'll do this and just build from the left to the right. However, you notice, hey, wait a second, my material isn't really in my jaws right now. So let's fix that. I'm just going to reach up and touch the blank, and I can set the position down here on the bottom. And I'm going to specify the position. Here's my easiest. I'm just going to say relative. I happen to know that I bored these jaws with a 3/4 inch pocket, so I'm going to relatively move my material minus 0.75 into the part. Okay, boom. There, now it moved it for me. And I'm going to do a little zoom action again so that you can see that the material, or the compass rose, there's a data marker right here to show me where my current G140 is located. That's great, because if this thing were all the way back here, I'd know, ooh, something's not right. You notice it's not quite perfect right now. I'm not stressed about that because there's no physical machine for me to come over and touch the face of the part. I'm calling that good. Now before I move off and send this to the collision avoidance software, as discussed in the previous video, I want to save the machining envelope. And by touching it, I'm going to call this the same name as the part program. So CAS demo, enter. The reason I make it the same as the part program, it's pretty self-explanatory. One, I want to know which program this machining environment relates to, but also if I've chosen to call up the machining environment from inside the program, I want to make sure that, yep, this program and this machining environment match. As soon as I say okay, oh hey, file already exists. This isn't the first take of this video? Yeah, overwrite it. Now that I'm done, I can exit and transfer to CAS. Out it goes. Let's go ahead and look. There it is. We're going to do the same thing for the subspindle. None, none. Edit parameters, check. None. Good to go. Okay, so now we'll do our process shape. We will add the jig, read the B210, and we will add a jig, read the sub jaws, and there's no blank on this one because, well, we're doing a pick-off. And before I exit, I'm going to save CAS demo. Make sure that this has the same name as the main spindle. Little footnote for you: if you're trying to call up the machining environment from inside the program, that's the term CAS CME in your program, CAS-ME. If you don't have a main spindle and a sub spindle machining environment that have the same name, it'll generate an alarm right away and say, I can't change the machining environment. So make sure that the main and the sub have exactly the same name. Now we can exit, transfer to CAS, and let's look at our machining environment. Boom, looks great. So now we've got our tools in place. That's good. We've got our machining environment in place. That looks good. Let's go ahead and hit cycle slam and see what happens. Oops, got a little turret index error, but that just means that I didn't send this guy all the way home. That's Charlie's fault. Let's go T1000. Execute. Okay, let's try it again. Magazine rotation interlock. How many of you have done this before? Currently, I can't move my magazine because it already started the next tool change. So I'm going to go to my machining operations button, find the ATC. Sure enough, look at that, sequence number 2. It'll back me up. Now it's number 1. Hopefully you won't have to deal with that because you guys never make mistakes, right? All right, let's try it again. Cycle slam, and we're off and running. We're going to crank up my speed. It's already at 200%. So now that we're sitting here operating, let's talk about the beauty of CAS and why we even went through the effort of doing all this population. We already know that this thing is designed to prevent me from crunching the machine. I'm going to induce a crunch here in just a second. Let's move this around so that we can see exactly what we're going to do. Angle change. This is where I plan on inducing the crunch. Oh, keep going. I'm going to slow it down as soon as it gets the drill into position. Okay, what I wanted to show you, the program is proper right now. Slow me down. What's going to happen, my drill is already oriented in a vertical orientation. That was awkward. See, there's my tool. It's moving down at a 10-inch diameter until it gets into position. Then it's going to drop down in X right here. Okay, it moved down to 2.7 so that it could clear my 2.5-inch diameter before it moved in. That little action right there is where I'm going to induce a crash. So let's go ahead and allow this to pop the rest of the way through. There we go, close enough. Now I will reset everything. Awesome. Okay, so now in my program, I'm going to find that 2.7 action on the second tool. There it is, M323. There's the 2.7. We just saw that that's plenty for us to clear. I'm going to change that to 2.0. We know that that's not going to clear. Select and quit. Oops, program's still running. You guys run into that one before? Main program execution just means that I tried to select the program while there was a command active. Just reach up and hit your reset button, verify the alarm, and try your action again. Okay, let's I did it with the ATC again. Let's go back myself out of the tool change. Boom, good to go. Okay, so now we're going to see it run one more time, that little turning tool. Let's make it big. All right. That's as fast as we're going to be able to. Oh, no, let's zip. There we go. Now it's as fast as it'll go. Excellent. Now we're going to get a tool change, and we should see our little owie poo into the magazine. Retract, go vertical, drop, boom. Now we have a collision block detected. Notice that the tool is red, the material is red. It's indicating which two items have made a crash. Now, you notice that the graphic here did not move. So if I had a physical machine attached to the software, the tool never would have gotten close to the material. The only time that a collision block detected alarm stops the machine close to the material is if you were moving the thing manually. Then it doesn't know where it's going. It just says you're too close to a collision and stops. However, in automatic mode, it's looking 2 blocks ahead of where the physical machine is to see, is there going to be an interference issue. That's also why when we're physically running the program, you'll notice that the cut itself is occurring before the tool actually moves in. That's because CAS is working 2 steps ahead of us. So now we've got the program. Let's go ahead and fix it so that the next time I do this, I don't arbitrarily get an alarm. Once you have completed your program, it's always a good idea to just double check and make sure that everything you've done has been backed up. We'll do that later. So let's double check. I'm going to look into my easy modeling function and make sure that I have a spindle 1 set up. There we go. A machining environment for spindle 2. That's good to go. There's my blank. It's in the library. My fixtures are all set. I'm not using any set tools here, and again, all of the tool massaging is on a different video. There's the individual tools. Hey, you know what? Why don't I give you another nugget while I'm right here? I get an awful lot of phone calls from people saying, hey, I'm having a tough time importing an STP from Sandvik or from one of the other websites. Let me show you a little something that I don't know if I bet you didn't know. I'm going to highlight the tool. Same goes for the holders. But if I touch read, I get this little F1 value that says catalog. By touching that, you'll notice I've got a whole boatload of tools that are already imported. Yeah, okay, those are everything you see here is a stick tool, and that's not necessarily complicated. Let's get into our Capto folder, and now I've got a big D folder, and look at this, an extensive Sandvik folder that's got a whole bunch of the tools that you may have a difficult time creating. Look at that. That's the big one right there that everybody owns and everybody fights with trying to get it imported with an insert. It's already done for you. It's inside the catalog folder. And as soon as if you find the tool you want sitting in the catalog, just say execute, and now that tool will reside in your library until somebody overwrites it. And you can use it as many times as you want, as many different versions of that tool as you own. So now let me go back here. I have everything saved. I'm all set to go. The only other thing that I may want to do is to export the tools that are being used in this. So I'm going to come over to my tool data tab, and if I arrow over twice, I have a button called tool data output. By touching it, it's showing me all of the tools that are in my data page, and there are the 3 that are being used because they're the ones that are mounted. So if I just select on for the tools that are currently mounted, and now I'll come over and designate where to output this data. In this case, it's going to be a new folder, and I will say okay, execute output, yes. Now it just sent the individual tools for this program into my MD1. So you notice I have 2 folders right here, big long stream, but that is representative of today's date and time. If I were to open that up, there are the tools, the tool files for that particular job. So if I wanted to make sure that this stayed around forever, I would probably take that folder and I would rename it to be CAS demo. Boom. Now I know that before I get ready to run this again, I need to highlight that guy, go over to my tool data tab, and this time I will TL data input. I will find the CAS demo folder, select on, and tell it I want all of those. Come on, baby. There we go. All choice. Select each of those guys and then import it. It's not letting me do it right now because they're already imported, but that way I can export the data and then import it back in. You guys with Multus and U machines, you probably won't do that step simply because you've already got the tools in this tool data. But if you are dealing with an LT or an LB machine, one that's a turret type machine, it's kind of nice because that tool data tab will populate the actual turret for you. However, on a Multus, you've got the magazine to deal with, and it doesn't know for sure where you put that tool. So, hope that helps you out. If you need any other advice, you've got an idea for a video you'd like to see, any kind of assistance, you can reach out to your local Gosiger application staff or just leave me a message in the comments. I do answer them as quickly as possible, and I'll be happy to create a video for whatever you've got on your mind. So thanks for watching, and we'll see you on the next one.